On this video, let's talk about theorems on tangents. But before we go over the theorems, let's first define and construct tangents on GeoGebra. By definition, a tangent to a circle is a line which intersects the circle in exactly one point. So let's first construct a circle. So let's have a point here. Let's call this point A. And then let's construct a circle. Click the center. And then a point. So we have a circle here. And then let's locate a point not on the circle. So it's outside the circle. And then GeoGebra actually has this tool which allows you to construct tangents by just clicking the point outside the circle and the circle itself. So let's click the point outside the circle and the circle. So these two red lines are tangents. Okay, let's just consider one of the tangents. Tangents. Okay. And then let's activate this intersect tool. Click the circle and then click the line. This point over here, let's give this a name, point D. Point D is what we call the point of tangency. This is where your circle and your line intersects. In order for us to enumerate the properties of tangents or the theorems related to tangents and circles, we'll be using this applet developed by Tim Brzezinski of GeoGebra, geogebra.org. The link to the applet is in the description box, just in case you want to interact with it. I want you to pay close attention on the applet as I slide the button slowly. This one, slide me slowly. Okay, let's see. So I'm sliding it slowly. Can you see the radius? And you know what this means? It says that the radius is perpendicular to the tangent line. See, it's perpendicular. That's basically our first property or first theorem. It states that a tangent is perpendicular to the radius drawn to the point of intersection. It's perpendicular. Theorem number 2 is the converse of theorem number 1. A line perpendicular to a radius at the point touching the circle must be tangent. We will be discussing the formal proofs of these theorems on one of our synchronous classes. So basically those are the first two properties of tangents. Let's continue sliding it. And we have this line segment OE. And then look at BE is equal to AE. Now, we can clearly see why they are actually equal, because if you consider triangle AOE and triangle BOE are actually congruent because of the hypotenuse leg theorem, and by CPCTC we know that AE and BE are congruent. That leads us to the third theorem, which states that tangents drawn to a circle from an outside point are equal. So in this case, AE and BE are equal. So those three are the theorems that we're going to consider when it comes to tangents. Let's apply theorem number 1 and theorem number 2. Let's have this example. So based on theorem number 1 or property number 1 and number 2, we know that the tangent line is perpendicular to the radius. So this is perpendicular. Therefore, APO is a right triangle. So if it's a right triangle, we can use the Pythagorean theorem. So by the Pythagorean theorem, we know that the hypotenuse is AO squared. So that's AO squared is equal to the sum of the squares of the legs. We have AP squared plus OP or PO squared. It's just PO squared. AO is x plus 7. So let's substitute the values. We have x plus 7 for AO. For AP, we have x plus 5. And for PO, we have x minus 2. Let's expand all the squares. Let's expand everyone. So we have x squared plus, we know this, x plus 7 squared is x squared plus 14x plus 49 equals x plus 5 squared, square of the first, plus twice the product of the two, we have 10x, plus square of the last, which is 25, plus x minus 2 squared, that is x squared, minus 4x plus 4. Then let's collect similar terms. We have x squared plus, let me copy this first, plus 49, and then let's simplify the right hand side. We have 2x squared, we have a 10x and a minus 4x, we have a 6x, and a 25 plus 4, that's 29. Okay, so we have a choice of whether putting everyone on the left side or putting everyone on the right side. So I think let's just put everyone on the right side para positive yung 2x squared. para positive yung x squared. So you have 0 equals, so you have 2x squared minus x squared plus 6x minus 14x. And we have a 29 minus 49. So let's have this one. Simplify ko lang ha. So we have 0 equals, we have x squared plus 6x minus 14x, that will give you a minus 8x. And 29 minus 49 will give you a positive 20. No, a minus 20. And I think this is factorable. Factor of 20 that adds up to 8 or minus 8. So I think it's minus 10 and a 2. So we have x minus 10 and x plus 2. And by the zero product property, we know that x minus 10 is equal to 0, or x plus 2 is equal to 0, which gives us x equals 10, or x, or x equals negative 2. But of course, we cannot accept negative 2 because why we can't accept negative 2? Eh, hindi naman siya na length. Well, because of this. If x is negative 2, then this whole thing will become negative 2 minus 2. So that will become negative 4. So hindi siya pwede. So, di pwede to. X minus 2, hindi siya pwede. Therefore, x is equal to 10. Let's verify what are the sides. Although, hindi kailangan yung sides, no? So, if x is equal to 10, then this particular side over here must be 15. The hypotenuse must be 17. And the one of the legs here must be 8. So we have 8, 15, 17. Which is actually a perfect, which is actually a Pythagorean triple. So one of the famous Pythagorean triples. We have 8, 15, 17. But anyway, the question is find x, therefore x is equal to 10.